Got it. All right. So lesson 3-10, adding magnitude and direction. We are ending with magnitude and direction instead of ending with component form. So just adding on one more step. Here we go. Bit of review. Magnitude of AB. This is how you do the notation. Magnitude of AB. What is the formula? I know. It's Christmas break, man. Does wonders to the brain in bad ways. Something with square roots. Something. No? Go back.
Square root?
Yeah, square root.
No, the square root of A squared plus B squared.
Man, Rochelle, how'd you remember? That's amazing. That's such a good
right?
job, yeah. Didn't look at Daisy's notes at all. All right, so direction of AB. Daisy, you want to read that out to us?
No, because he was being sarcastic.
Daisy, you got this?
It's like the tan -1.
Tan and -1. That's arctan of?
Arctan, yeah, sorry. B over A.
Yeah, and B always goes on the top. So B is the y coordinate. So the y coordinate always goes on the top. Just remember that when you're doing arctan to find your direction. And to find your component from...
Wait. Can you repeat that?
So the y. Remember how B is the y, it's the second coordinate? The y always goes on the top. So if I were to rewrite this with x's and y's, it would be arctan of y over x. That's another way of writing it. It comes from the properties of SOHCAHTOA. I could go through it again if you would like. Okay. Components from magnitude. So that's the stuff that we did in our last lesson yesterday in our review. So if I have magnitude and direction, how do I get back to component form?
It was okay. You do V. Oh no, wait. So the lines, the two lines U, two lines plus. Times. Cosine.
Is it sine or cosine?
It's cosine and sine, right?
Yeah.
Right?
It goes cosine and sine. Cosine of the theta and sine of the theta. There it is. Nice. Make sure you have it in your notes. If you copy it down, if you write it down, it does help you remember it. At least a little bit. Some people more than others, for sure. Cool. So we know how to get to component form from polar form. All right. So example 1, this is a review from yesterday. But I'm going to add on one more step at the very end to just show you that last additional step. Then we'll do one more example. Actually, 2 more examples, depending on how many we need to do. We don't have to do all the notes. All right, so here is your problem. Find the component form of V plus W. Vector V plus vector W. Round to the nearest thousandth. Thousandth. There we go. All right, so problem. We can only add when they're in component form, but it did not give us polar, or it gave us polar form. So we need to convert this polar form into component form. Tell me what to do.
Oh. 5 cosine of 50.
Oh. Right.
Yep.
Plus 8 times the cosine of 160.
Ooh, nice. We already have shortcuts. I'm liking this. So that's the x coordinate of when I add them, and then the y coordinate is going to be
5 sine of 50.
and then Daisy do the rest.
8 sine of
160. There it is.
That's how you do it?
Yep.
Yeah,
So
yeah.
this is the x. Oh wait, that's the y. This is the y coordinate. This is the x coordinate. And we're adding them already because we're shortcutters like that, and that's super awesome. Shortcuts mean that and if you come up with the shortcuts on your own, that means that you really understand what's going on.
How's it a shortcut?
Because the old-fashioned way is converting this one, the x and y component, and then once you find the x component, add it with the x component of this. But you're just adding them all at the very beginning. The old-fashioned way was just to convert this entire vector into component form first, and then add it. So let's go ahead and do that on our calculators. Let's open up calculator. Someone check my work. So I have 50, and then cosine of 50 is that, times 5, and I get that. I'm going to store that to memory by doing m plus, and I'm going to do what is 160 times, I'm going to do the cosine of that, multiply by 8, and I get that, So I'm going to add this to my memory recall, so plus memory recall, and I get 4.3036, and I'm rounding to the nearest thousandth. Cannot pronounce that word today. I don't know what's going on. So that's, I have tenth, hundredth, thousandth, so I'm rounding to this decimal place, so it's negative 4.30.
Oh, 4.
Yep. So negative 4.304, comma, 50 sine times 5. Let's just write it down, old-fashioned. 3.8302.
Why is it 2? You don't need that.
I'll round at the very end. 160 sine times 8 plus 3.8302, and rounding, that gives us 6.567. No, 6.566. 6.566. Daisy, did you get that?
I got it.
Nice. Phone calculators are, for some reason, easier to use than this.
They're the same ones.
They're the same ones?
Yeah.
Did you use memory plus or at all? Nope, you just did order of operations. All right, I guess I need to get used to that. All right, so sorry about that. New step. So instead of ending right here, now I convert back to angle and magnitude. How do I do that?
What?
So I have component form right now. This guy right here with parentheses around this is called component form. How do I convert from component form to magnitude and direction? Well, we did this review, Mr. Sindel, at the very top, which says you can find the magnitude and direction by doing these two formulas. What? So let's go ahead and do that. So we'll just round this. We don't have to have it stored perfectly in our calculator. It should be fine. So we need to square this, add them together, and then take the square root of that. That will be the magnitude. So 4.304 squared, and I'm going to add that to 6.566 squared, and I get 61.63, and I'm rounding to the nearest thousandth, so I'm going to round that up to 7, 61.637, 61.637, that's going to be my magnitude. So vector V plus vector W, your magnitude is this guy.
You found that.
Wait, whoa. Slow down.
Okay.
So for the magnitude, you have to
Plug in those component forms into the.
Oh, okay. Never mind. Sorry. Okay.
I'll write it down. Negative 4.304 squared, and then we had to add that to 6.566 squared, and then all of that was square rooted, and that gave us this guy right here. More or less. So far, so good?
Okay, yeah.
All right, how am I going to find the argument? How am I going to find that theta?
You're going to have to do arctan.
The arctan of 6.566 over negative 4.304.
Over negative 4.304, yep. Negative 4.304. All right, let's go ahead and do that. So on our calculators, 6.566 divided by 4.304, make that negative. That is this decimal. So this is this decimal, and then I take the arctan of that. So I have to go second tan, and I get negative 56.755. Is this in the correct quadrant? That's a good question. So look at the component form right here. Component form, I go negative in the x direction and then positive in the y direction.
Oh, it has to be on the second.
So it should be in the second quadrant. Yep. Is this angle right here in the second quadrant? So I need to
Add 180.
add 180. There it is, 123.245. 123.245. 245. So that equaled minus 180. What was it before? It was negative 56.755. And then we'll make a note here. This is the wrong quadrant. It was in quadrant 4. Should be in quadrant 2. I guess I should do Roman numerals. Roman numerals we always assume to be quadrants. So quadrant IV. All right, so far so good? All right, let's write out our general procedure and then we can decide whether or not we want to try another problem. So the general procedure is this. Get both vectors in component form. We did that by doing this procedure up here. We got their x and y, and then we added. And obviously, we do x's with x's, and we do y's with y's. You don't add x's and y's together. Just x's with x's, y's with y's. Then what do we do after that? Once we got to this step, once we got to component form, we needed to do this step. What do we do down here?
You find magnitude.
Then find magnitude,
And direction.
magnitude and direction, or magnitude and your theta, using formulas. Perfect. All right, now that we're fast with our calculator, do you want to try one more, or do you want to go on to the homework? It's up to you.
Let's do homework.
Homework, Daisy? Okay, that concludes the lesson. Go ahead and write your summary. That general procedure or some form of that needs to be in your summary. That's probably the most important thing from this lesson.